Hello, my wonderful computer science students. Welcome to another lesson in our current unit, Unit 1, using objects and methods. This is going to be lesson 2 from this unit where we're going to talk about variables and data types. I'm Goldie if you're new here, and I'm ready to take you through this lesson and teach you all about these essential components of the Java programming language. So without further ado, let's go ahead and dive into first talking about keywords in our Java program. What's referred to as a keyword is something that has a special meaning to the compiler, so that when we create our program, these are almost reserved words in the sense that we can't use them as our variable identifiers. Okay, in your IDE, whichever one you use, they are usually a special color. In our IDE, they are going to be blue. So like public class, static void, string, and a few others like protected, return, true, false, null. All of these keywords have a special meaning, and we cannot use them as identifiers for our variables. Okay, we're going to learn about what all of them mean at some point in AP CSA, but know that they are special and they can't be used for our identifiers. Now, what is a variable identifier? So identifiers are the names that identify, clever, the elements in a program. Now, these are going to be the names that we give to variables, and variables in a program are going to contain data that we use in our program, right? So these identifiers identify data. And an identifier in Java, this is very specific to the Java syntax, an identifier can only be letters, digits, or it can have an underscore or a $sign. There's no other special character that it can be. Okay, you can't use braces. You can't use like the % sign, right? Letters, digits, underscore, and $sign are the only ways you can use in an identifier. Only symbols you can use in an identifier. It can't start with a digit. A little strange, but you can't start with a digit, and it cannot be one of the keywords that we went over on the last slide. Okay. So another thing about identifiers, besides just the general syntax rule, is being descriptive with them is the ideal in a program. Okay, and we always want to stick to good programming style, right? So for example, X is okay as an identifier, but in your program, if it's used to represent the number of teachers that you have, using the words number of teachers is more descriptive and would make us a better identifier in your program. Okay. Identifiers are case sensitive. So if you have a variable that holds the area of a whatever you're looking at, right? The area. These three different types of areas with different capitalizations, they are three different identifiers, and they're going to represent three different pieces of data in your program. And again, just part of good style is to not mix these up. So like, for example, if you did have three areas that you needed to keep track of in your program, you wouldn't name it area with three different capitalizations. You would name it area 1, area 2, area 3. Okay. So descriptive, distinct identifiers are the key to good programming style. And then the last thing, if your identifier has several words like number of teachers, we usually concatenate them, right? We push them together. We make the first word lowercase and capitalize the first letter of each subsequent word. This is also called camel case. Okay. So for example, if we have dog name, dog age, number of dogs, notice how dog name, lowercase d, uppercase M, and we'd stick them together, right? Dog age or number of dogs. Okay. And that's just programming style. You can call all of them XYZ. Okay. But when you're reading your program and you're working with data, you want to know what these variables are storing and what information they're storing. So we try to be descriptive with them in our program. Okay. Okay. So I keep saying variables, right? We use these identifiers to hold data, and the data is in the form of a variable. Think of variables as a container in memory. Their variable is going to contain some single piece of data. When we declare a variable, we're telling the computer to allocate some space in memory for something, okay? We want to tell it the name of the thing, also what's called an identifier, so that it knows how to find it later. And we also need to tell it what thing it's going to be storing, a data type. So if we have a container, we want to know, okay, what are we storing? What type of variable are we storing? And then what's that name going to be? So those two things together are going to be making up how we create these variables in our program, okay? Now, when we talk about the data type, okay, what do you mean we have to tell this container what it needs to contain? That's called a data type. We're going to say, okay, what data type are we going to put in this container? There's 8 primitive data types, and we say primitive because they are built into our Java programming language. So each of them, we're going to cover here, each of them require a different amount of memory to store them, memory space. So by telling Java, hey, we're going to make an integer, right? Knows it needs this size container. But hey, we're going to make a decimal, so we need this size container. Okay. So different data types have different containers just based on the amount of information it can store. So we have to say, hey Java, we're going to use this data type for this container. Now, again, there's 8 of them, okay? The first 4 data types are all going to be dealing with integer values. So like a byte. A byte is a data type that can hold the range of values from negative 128 to positive 127, okay? A short holds this to this. I'm not going to name off the numbers for you. An int holds this to this, and a long holds this to this. Whew. Okay? So all 4 of these are going to store integer values. They're going to store whole number values. And you can see how we have a range of values it's going to store. So if a variable knows it's going to store a byte, then it knows it needs like this little container, right? Because the possibilities of a byte are very small in terms of range. But if it's going to store a long, I know I need this size container because it could potentially store a very large number. Now, for example, all of 4 of those can store a 0, right? All zeros in all of them. So if you needed to store a variable of data type or data of 0, you could use any of them, okay? But if you needed to store a really large or a really small number, you would need to make sure you're specific with which data type you use. Okay, so all of these are integers, but on the AP exam for this course, they only test you on ints. Okay, so because they only test on ints, in this course, we will only be working with data type int to store integer values. Okay, so you might see byte, short, and long in other programs if you look at other example programs online, but we are not going to use any of those in this course. We are just going to use int to store integers because that's usually big enough for our purposes. Next, we have the 2 decimal types. We have float and double. Okay, so a float stores anywhere from this value raised to the 10 to the 38 or this value, right? Or double. Again, you don't have to memorize these numbers, okay? It's just fun information, right? So you can see a double stores a lot more information than a float, okay? But both of them store decimals. Okay? So if you need a decimal, you could use either of those, double having a bigger container than a float, but the AP exam is only going to test double. Okay? Only going to test double. So we're only going to use double. Next up, we have our 2 special data types, char and Boolean. Okay, char is thousands of characters, glyphs, and symbols, anywhere from things you see on your keyboard to having different languages and their special symbols as well. Char can hold anything, but it holds a single character at a time. Okay, just a single character. And then Boolean has the values of true, false, or technically it could be a null if it doesn't have any value. But a Boolean holds a value of true or false. Okay. The last one, which is not a primitive type, is what's called a string. And a string data type can hold any string literal between quotation marks. Okay. Now, all of these are specialty variables, and only Boolean and string are going to be on the AP exam. Okay, so a char holds a single character, but Boolean and string, those are going to be the ones on the AP exam. Okay, so a Boolean, again, true or false, and then a string is going to be anything between two quotation marks. It could be a single character, or it could be a sentence, a paragraph. It does not matter. It stores anything that is between two quotation marks there. And it's not a primitive, but here are the 8 primitive data types. So these are built in. Technically, string is also sort of built in. We treat it very similar to a primitive, even though it's technically not a primitive. Okay, but we're going to treat it like one for the purposes of this course. Again, there's a lot of nuance around what exactly a string is. We'll get into it a little bit as we learn more. But for right now, we're going to treat this data type like it's a primitive. The only difference is you notice all these primitive types start with a lowercase, whereas string starts with an uppercase S. Okay? So when we are declaring data types or creating variables, we want to be aware of that. String starts with a capital S, and it needs to start with a capital S, whereas all of the other data types start with a lowercase letter. Okay. So let's get into declaring a variable. So this is going to be how do we set up a variable in our program. Okay. So to declare it, again, you have to identify what data type it's going to hold, and then what we're going to name that container, right? So it's kind of like if you put your leftovers in a Tupperware container, you want to, get the appropriate size Tupperware container to hold it. And then maybe you put a label on it, like the date it was, created, made, right? Something to identify it with. And then in a lot of the same ways, that's how these data types and variables work in Java. So here's the syntax for it. Here's like the skeleton. We start off with the data type, a space, and then we put the variable name. And then because this is going to be a statement, we end all statements with that semicolon. Okay. So here's going to be an example. Practice writing the code on the line that declares the correct variable. Okay. So this is declaring. This is creating the space in memory and giving it a name. We are not actually giving it any data yet. Okay. Declaring variables just declares like, hey, I have this storage container. This is what I'm going to put in it, and this is what I'm going to call it. But it doesn't actually have any sort of data in it yet. So if I want to declare number to be an integer variable, I would write int number semicolon. Okay. So number is my identifier. Int is my data type. If I want to declare GPA to be a double variable, I would do double GPA. Okay. GPA is my identifier. Declare answer to be a Boolean, it would be Boolean answer. Okay. And then declare name to be a string, it would be string name. Okay. So all of these, again, they are creating Tupperware containers for you to hold the data eventually. Eventually, we're going to put a number in that container. Eventually, we're going to put a GPA in that container. But right now, there's no data in it. We are just declaring space in memory and using an identifier to become associated with that space. Okay. So how do we actually put data into these variables? That's where assignment comes in. So after you have a variable, after you declare it, you want to use it to store information. And each variable stores a single piece of information. Okay? A single piece of information. So in order to give it to the variable, we have to use what's called the assignment operator, which is going to be the equal sign in Java. The variable name will go on the left of the equal sign, and the value goes on the right of the equal sign. And that's very important. The order of that is very important, and it absolutely matters. Okay. On the left is the identifier name, and on the right of the equal sign is the data you give it. Okay. So this is what it looks like. You use the variable name on the left, the equal sign, and then I say expression, but again, it's whatever data you're going to give it. Okay. So using those 4 identifiers we just created, let's say I want to assign 5 to number. So the number I want to put in the container is 5. I would do number equals 5 with a semicolon at the end. Again, these are all statements. If I want 3.9 to GPA, I say GPA equals 3.9. Okay. This, for any of them, switching this is not allowed. Okay. We do not do that. I know in math, it doesn't matter what is on, x equals 5 or 5 equals x. It meant the same thing in algebra. That is not the case for programming. Your identifier has to be on the left and the data has to be on the right. If I want to assign true to answer, I say answer equals true. Assign your name to name, I would do name equals, and then my name is Kayla. So I'm going to put that right in there. Okay. So these are all assignments. So we talked about declaring space. We talked about assigning data to those. The last thing we can do with variables is initialize. So initialize is just a fancy word for declaring and assigning all in one line, okay? Because right now we did int. We did int number. That was declaring, and then we did number equals 5. Okay, so we did both of those, and that took 2 lines of code. Int number equals 5. We can also do that just in one line there. Okay, so to do that in one line, let's say we say we want to initialize the integer variable number to 5. What we do, we take the data type int, the variable name number equals, and then 5. Okay, so here's kind of the general expression for it. And this is what it's going to look like in practice. Int number equals 5. Double GPA equals 3.9. Boolean answer equals true. Or string name equals Kayla. Okay. So you can use declare and then assignment, or you can just initialize all on one line. It is up to you. When we get into writing programs to actually solve problems for us, sometimes we prefer one way over the other, just in terms of solving the problem, but you'll see those when we actually get into applying some of this. Okay. For right now, just know those are the 2 ways we could do it. There's also this special initialization I want to let you know of. This is not on the AP exam, but you'll see this a lot. I sometimes use it. It might be useful for you, so I want to point it out. If you have 2 or more variables of the same data type, you can write the data type once and then assign the values to each variable in the same statement. So let's say I have 2 numbers called number and other num, a 5 and a 6. And since they are both integers, I can say int and then number equals 5, comma, other num equals 6, and then end with a semicolon. Okay, so that is creating 2 containers, number and other num, and assigning them both data values. Okay. Same thing if I had string name and I had 3 names. I had my name, middle name, last name. Okay, name, middle name, and then last name. Since they're all strings, they all have those quotation marks around them. And then every time you do the special initialization, you separate it by commas, and then you put the semicolon at the end. Okay. So if you see that, if that slips into code, just know that that is legal, that's allowed, that's a thing. So now you don't have to be surprised if you see that. Now let's talk about size limits, because these containers that we have, they're all different sizes, right? I say if you have a small integer, maybe you want a small container. If you have a big integer, you want a bigger container, okay? Now the reason why we might want to do this in a Java program obviously has to do with space in your computer, right? And memory space. There's a finite amount of space that you can use in a computer when you are running a program. Okay. Now, us in this class, that is something we never have to worry about, okay, because we're not dealing with the type of data that is going to come anywhere close to reaching those limits. But that is why we have different variables to account for those different size limits, okay? What we are interested in is if we try to fit something in a container that is too big, right? So if you think of a container, if we try to fit my leftovers in a Tupperware and my leftovers are smaller than the container, that's not a big deal, okay, right? I can handle that. I put the smaller leftovers in my container and it's okay, right? But if I have a container of leftovers and I try to fit the food in there and if there's too much food, it's overflowing, then that's not okay. That's a mess. That's a problem that I got to clean up. And it's that same thing with these data types, okay? Each data type, each container has a size limit. If you try to fit something smaller, well, that's okay. You can fit something smaller inside a data type. But if you try to fit something larger, you're going to get an error, okay? You can mix data types, but you have to observe these size limits, okay? So let's look at our 4 integers. For example, okay, again, we only deal with int in Computer Science A, but the visual is pretty good. Or excuse me, we're looking at our 3 integers and our double. Okay, we're only dealing with int and double in AP CSA, but the visual is helpful, okay? So the smaller data types can fit into the larger data types, right? So if you try to fit a byte into a short, you're not going to run into a problem, okay? Byte being, let's say you have a 5. Okay, oops, I tried to write it red on red and it didn't work. Let's say I have a 5 stored as a byte. If I then tried to store that into a short, well, the short can store a 5, no problem, right? If I tried to store that into an integer, 5 can get stored in an integer, no problem, okay? Fun fact is a double has more space than an int, so you can also fit a 5 into a double, okay? You can fit any integer into a double, that is okay. But the opposite way is not true. The larger data types cannot fit into a smaller data type. So we would not be allowed if we had like a 3.5, we cannot put a 3.5 into an integer. Okay? That would be considered an overflow error, like our leftovers overflowing, okay? So because, and this is, I narrow it down to int and double because these are the 2 data types we're working with in CSA. Because a double is larger than an integer, a double can hold an integer, like I said, but an integer cannot hold a double. So what that looks like, these are 2 legal ways to store data in a double. I could put 4 into an identifier called value, okay, that's a double container, or I could put 4.0 into a number in a double container, right? Totally legal. A double can hold integer values, okay? What would be illegal is the other way around. If I tried to store 4.5 into a container that was expecting an integer, I would get what's called an overflow error, okay? An overflow error is a type of runtime exception sometimes, okay? Sometimes the compiler will catch this value. Like if you actually tried putting this, the compiler would catch this. And it would say something about, I think it's like lossy conversion. Basically, don't do it, right? It'll say, hey, this is a problem. This line of code right here, you're trying to put a decimal into an integer value. There's an error, okay? That's what the compiler would say. If something happened later on in your program and your program tried to store a double into an integer on its own, then you would get an overflow error. Okay, that is going to run in your program. Okay, here's another example. Even if you want it to be an integer, by putting that decimal there, you are creating a double value. Okay, Java reads this as a double, and it reads it as you trying to put a double into an int, and it will not allow that. Okay. Now, there are ways around this in terms of converting between the 2 that we're going to get into in a couple lessons, okay? But for now, know that we can fit an int into a double, but we cannot fit a double into an int. Okay, let's expand just a little bit on the strings versus primitive idea. Now, a string can hold any characters. It just has to be enclosed in quotation marks. You can make a new string together by doing the plus symbol between them. We're going to talk a little bit more about that plus symbol in lesson 3. But if we have 2 strings that we want to put together, we use that plus symbol to what's called concatenate them. Okay, concatenation. And another thing to know with strings and primitives, if you mix a string with a primitive, it will result in a string. Okay. If you mix two primitives together, right, 2 plus 3, that's going to also give you a 5, right? I didn't have to think about it. I knew the answer was 5. Okay. But 2 plus 3 is 5. Two integers added together are going to give you an integer. Okay. If you have a string, however, with a primitive, you are going to get, it's going to treat this primitive as a string. Okay, so you're going to get the value of 23 as a string. Okay, because a string can hold any character at all, including numbers. Okay, including numbers. So that's very important to know. Again, we'll talk about mixing data types because, you know, what happens when you mix an integer and a double. We're going to talk about that in a little bit here in the next lessons, okay? But for now, we're just kind of introducing this idea of mixing the data types. Okay? So we're going to finish off with a couple of legal and illegal examples of initializing variables, okay? So legal would be saying, hey, I have this container A and I want to store a 5 in it, okay? This is legal. We put it in quotation marks. It's going to store a literal 5 in there. Okay. And I have these little boxes to try to get you to visualize those containers, right? If I have something like this, string B equals example plus 5. As I said before, if you have something in string in quotations pushed together with something else that's not in quotations, Java is going to treat that as one giant string. So what gets stored in our variable B is going to be example 5. It's going to just push everything together. Okay. C, our example plus true. Again, true is a keyword that is a Boolean value. It's stored in a Boolean data type. But if you mix a string and a Boolean data type, you still get a string. Or D, our last example. Okay, true plus example. You could have it vice versa. Okay, it'll still be pushing them two together. Now here would be illegal assignments for strings. Okay? String x equals 5, or string y equals true, okay? Or really anything. Okay? String z equals hello. Okay? Why are all of those illegal? Because there's no quotation marks around them. Okay? In order to become legal, they need quotations. Okay? Or they need to be mixed with something with quotations. Okay? They need to be mixed with something with quotations. And that would be legal and illegal ways to work with strings. Okay? And strings and primitives. So that was a rundown of all of the different data types and a little bit about declaring, assigning, and initializing them. In our next lesson, we are going to go over expressions and we're going to use these variables a little bit more in our program. Until then, if you like this video, please click the like button and subscribe to my channel for more computer science content. And until then, I will see you in the next video and have a great day.